Unit 7, Lesson 3. Unit 7, Lesson 3. So in this lesson, we'll be solving trig equations involving multiple angles. So what that means is we have multiple locations. So we're going to get more than one answer, essentially. Okay, so graphically, so consider the equations cos x of negative root 3 over 2, cos 2x of negative root 3 over 2, where x is a degree measure. Use a graphical approach to determine the solution to the equation of the first one, and a graphical approach to the solution of the second one. Okay, so let's go ahead and put these in our calculator together. So I'll do that with you here. Yeah, so we're on page, if you're not with us, 609. Okay, let's put these in here. All right, so clear that, clear that. Okay, so we're going to look at cos x. I'm going to do the intersect method. Okay, so I'm going to put 1 in y1, the other side in y2. So I'm going to put in negative root 3 over 2. So we go negative root 3 divided by 2. Okay, hit graph. Okay, so we see that we have two solutions. So why don't you guys go ahead, I'll stay on the calculator for now, but why don't you guys go ahead and draw that in the left section there. That's the left graph as you guys get that put in. Okay. And so it looks like, let me change here. In the calculator, they went in degree mode. So we're going to go degree mode here. Let's see if that changes anything. Yeah, it changes a little bit of stuff. So we just got to change our window, because our window now, we want to go like 0 to 360, right? So 360, let's go by, I don't know, let's go by 30. And the rest of that stuff should be still okay. See? So we just changed this, and now it looked weird. The reason it looked weird because we only went to 6. So it was only looking at 6 degrees of your graph, right? So that's why it looked different. So now we're back to normal. So it's degree mode. So it's in 30-degree cuts, so you can see 30, 60, 90, 120. That's what it's going by. So we can actually even see here kind of what the answer is. This intersection's happening here. This intersection's happening here. 30, 60, 90, 120. Looks like 150. We'll double check. Looks like 210. We'll double check. So we're looking at 150 and 210 by our scale. Let's go ahead and just do intersect. Second trace, 5. Okay, 210 is 1, so that's good. Second trace, intersect. Get the other side a little bit here. And 150 is the other one. So 150 and 210 is what you're writing in there for part A. Those are the solutions to part A. Okay. Now we're going to do the exact same thing, but we're going to put a 2x. How do you think that's going to change the graph? We know what that 2 is going to do. What's that 2 going to do? 1/2. 1/2. So is that going to shrink it or make it wider? It's going to shrink it. It's happening faster. So watch what happens with your curve here. So go to y equals. Just go over here and insert a 2x in here. 2. Now graph. See, we got more curves happening because it shrunk down. So now how many solutions do we have? 4. Okay, within that that range. So, and they're not really right on a bar, so we're going to have to do second trace intersect 4 times. In this case, we are going to solve algebraically, but just for right now, I'll just do 2, and I'll tell you the other 2 so we can kind of keep going. Enter, enter, enter. So the first one is 75. 30 still, I didn't change. Oh, it was 0 to 360 by 30s for x. Kept the y the same. Second trace, intersect. Let's find the second one. The second one right here is 105. So 75 and 105. The other 2 are, if you want to write those down, 255 and 285 are the other 2. 255 and 285 are the other 2. So 75, 105, 255, 285. Okay, so coming off the calculator now, let's go back to the workbook. All right. Whoops. Okay, so compare the solution to the equation. So the number of solutions was twice as many. So 2 for the first, 4 for the second. So notice that by putting a 2x there, our solution number doubled. Okay? The values of x. The first values in B are 1/2 the values in A. So if you look at like the part A, we had 150 for the first value, and then part B, we had 75. So we understand that, too. You guys said horizontal stretch by 1/2, right? So just half that value for my first one. Okay, and then for my second one, we also had 210, and so we had 105, and then we had half of that, which is 255, and then we had 285. So we understand that these two right here come from half of these two. Well, why did we get 2 more? Because by shrinking down, it came up again. And so by shrinking down, it created 2 more opportunities for it to cross. So these two relationships make sense. These are the new guys that get put in because we have more room. Okay? All right, so complete the following. The general solution to cosine x -√3/2 is, so the general solution would be 150 plus 360n, and then 210 plus 360n NEI. The general solution to cosine x consists of 2 sets of answers which differ by, they differ by how much? 60 degrees. Okay. Oh, wait. What are they saying here? Let me read this. General solution consists of 2 sets of answers which differ by, okay, they're talking about writing the general because the period's 360. And so then, remember I talked about yesterday about how when your period changed, then that n number changes, right? We kept going 2 pi all the time because our period didn't change. Now our period changes, right? So look, the general solution of 2x consists of 2 sets of answers which differ by, okay, right, 180 degrees, half of the normal period. Let me say that one more time. You guys are fading on me. Stay with me. We know that this right here is a horizontal stretch of 1/2. That changes that's my B, so my period goes from 360 to 180. That's why these right here are 180 apart. That's 180. That's 180. Okay, so that means we change our general solution for the second part to 75 plus 180n and 105 plus 180n. So that's the only way that your period changes from 360 or 2 pi. Right, so if there's a 1/2 in the equation, then it'd be 720. Yep, good question. All right. Any other questions there? Who remembers what's the period of pi, or what's the period of tangent? I just said it. It's pi, 180. Okay? So given tan 2x √3, find the exact values using graphical approach. So let's go ahead and look at tan real quick. I'll put this in the calculator as well because I want to make sure you guys have seen the tan graph because some of you guys still haven't done that problem I told you to do, but that's here or there. We want tan to be just √3. So we want second √3, and it's tan 2x. Tan 2x. Okay, so we're putting our calculator. All right, so of course they changed it back to radians on me, so I'm going to go back to my window. I'm going to change it to 2 pi again, 2 second pi. And I'm going to go by second pi divided by 6. That's 30 degrees. Yep, 2 pi. I'm going to go back to my mode and change it to radian. And now I'm back to being OK. So there is a tangent graph for you. Yeah, tangent's a lot different because tangent's not continuous. It has all those vertical asymptote breaks. Looks like snakes. Okay, so second trace, 5. Okay. and you can just move down. If you just keep hitting left, it'll go to the next snake. Okay, so there it is. I'm going to hit enter here. I'm going to find that first intersection point. 0.523. So remember, how do we convert that to radians? What's the process of the calculator? Or, which like we talked about last time, remember? Go back, quit, x, enter, divide by pi, enter, math fraction. So your first answer is pi over 6. So pi over 6 is the first location. Okay, I'm not going to do that. I'm not going to do that 4 times, guys, but that's the intersection spot, yeah. Okay, so going back to the workbook, our solutions here in exact form are pi over 6, which we just got, pi over 6. It's going to be 2 pi over 3. It's going to be 7 pi over 6. And it's going to be 5 pi over 3. So you can kind of see that it happens every, so pi over 6 to 7 pi over 6, what's the difference between those two? 1 pi, right? 6 pi over 6. 2 pi over 3 to 5 pi over 3, what's the difference between them? 3 over 3, so 1 pi. So these are going by pi by pi. So your general solution for this is pi over 6 plus pi n and 2 pi over 3 plus pi n, n-e-i. I'm going to write it separately. You could write it, they do write it simplified way too, but because it is technically 4 pi over 6. Actually going by a half every time. Do you guys see that? Do you see how 2 over 3 is 4 pi over 6, right? 2 pi over 3 is 4 pi over 6. And so from 1 pi over 6 to 4 pi over 6 is how far? 3 pi over 6, which is pi over 2. So you actually combine these to simply pi over 2n. Sorry, with the pi over 6. You don't start at pi over 2. It's pi over 6 plus n pi over 2. So this is a condensed version of writing it. Okay, so the general solution consists of answers which differ by pi over 2. Because the graph y equals tan 2x is a period of, so period of tangent is pi. What's that b there? That's 1/2. So pi divided by 2 is the pi over 2. That's where it comes from. This is our period change to pi over 2. All right, algebraically investigating here. Is everybody okay? Okay, so let's look at this here. So algebraic investigating. So sine 3x equals root 2 over 2. Okay, so x defines the domain of 0 to 2 pi. Then g of x is now defined where? Let's see if you can figure this out. So it says if x is defined for the domain of 0 to 2 pi, then 3 of x is defined where? So it's where is 3x defined? So it'd be just 3 times. Now that's because we're just talking about we're talking about, let's see here, what's the best way to explain that? No, it is for the stretch, you're right. So I'm trying to figure out the best way to explain this. Okay. So x is on the period of 0 to 2 pi, right? And so 3x is in twice that size. But we know what that's going to do. It's going to shrink our graph and give us more solutions. So it's kind of thinking about the reverse side of it, that we're actually spacing out the opportunities for it to cross. So like when you shrink it down, it's going to happen. So like if it happened twice in one period of 2 pi, and I shrunk it down by 3, it's now going to happen 6 times, right? That's kind of what this is telling you. Because 0 to 6 pi is 3 sections of 2 pi. Okay, so it's the thinking. They're just talking about just this x in general. They're not saying that your period's 0 to 6 pi. Okay, So, yeah, so let's just keep going with it, and I'll try to keep explaining that part. I kind of don't like that they're doing that because I know why you're confused. But sine of 3x equals root 2 over 2, that's in quadrants where? So where is sine positive root 2 over 2? 1 and 2, right? The reference angle, we know what that is. Root 2 over 2 is 45. Okay, good. Okay, or sorry, we're doing radians, so they want pi over 4. Okay, 3x then is pi over 4 or 3 pi over 4. That's the two options. So 2 pi plus that to get that first new section. Okay, what'd you say? Yeah, well, they just wrote pi over 4. Yeah, pi over 4, 3 pi over 4, pi over 4, 3 pi over 4. Okay, so they're just kind of proving the point here. So let me try to keep explaining what I was saying. So guys, pay attention here. Whoops. Sure, let's go green. Okay, so this is the first section, right? Adding 2 pi puts me in the second section, and then the third section. Think in terms of 2 pi's. Okay, think in terms of 2 pi's. So we know, okay, I know this is hard to understand. We know that the 3 is going to shrink my graph down. What it's going to do is going to make my graph act like it's on a 6 pi. It's going to make the graph act like it's on a 6 pi turns, because it's going to happen 3 times more than usual, right? So when you shrink down, you're getting 3 times more answers than normal because the graph's acting like it's on a 6 pi period, but it's really not. It's going to 2 pi, but it's happening 3 sections. So let me draw it. So if I'm 0 to 2 pi, let's just talk about sine. Let's just be very general here. Sine starts here, it goes here, comes down, goes there, right? 0 to 2 pi. If I do the 3 here, everybody in here understands that's going to make it shrink, but it's going to make it happen more often. So what it's going to do, it's going to make it go like this. And this is going to be rough, so be generous here. One, two, nope. And I need one more little half here. Told you to be generous here. Like that. That's what's happening. So what I'm telling you is that this to you is, here's one section of it, 2 sections of it, 3 sections of it. That's why they're telling you 6 pi, because it acts like it's going to 6 pi in terms of how many times it's happening. Okay, so then you have, for example, we know pi over 4 is the answer, right? So pi over 4 happens like right there, and then 3 pi over 4 happens right there, right there. There's your answers. You have 6 solutions. Is that making sense? Yeah. Yeah. More colors. Yeah. Yes. Okay. All right. So then what it says here is that, so in 3x, so what's happening, these values I just put blue dots on, they are pi over 4, 3 pi over 4. So that's these two, 1, 2. Okay. Then it's 2 pi plus that. What's 2 pi in terms of force, guys? 8, right? So 8 plus the 1. So the next spot's 9 pi over 4. That's this spot, this number 3. That's 9 pi over 4. Okay? And then I'm going to add 8 to 3, so 11 pi over 4. That's this spot. Number 5, I have to do now another 2 pi to that. So I'm doing 16 pi over 4, because 8 over 4 is 1 pi, right? Or 1 2 pi set. 16's 4 pi set. 16 over 4. 16 plus 1 is 17 pi over 4. That's right here. And then the last one is going to be 16 plus 3 for 19 pi over 4. Those are all of your solutions that we expect.
Why do you add 2 pi first time and 4 pi the second time?
Say that one more time.
Like, why do you add 2 pi for your second
I'm really adding, so it's because I went back to the original, Leah. You could have added 2 pi to these.
Oh, okay.
I just went from there.
That's
Yeah. So you could have went 9 pi over 4 plus 8. Yeah, same thing. Okay, so now what's this saying? So now if they're x's, if I want to solve, this is where it's going to make the connection. Now if I'm saying in terms of x, what would I do to solve for x for all these? Divide everything by 3. Pi over 12. 3 pi over 12, which is pi over 4. 9 pi over 12, which we can reduce. 11 pi over 12. You guys, this is going to make so much sense now. I'll show you. This is going to be great. Sorry, I'm optimistic. Okay, so check this out. So since we solved for the actual x there, now look what happens. This is what throws it back into the one full turn. Because look, pi over 12 is this actual spot on a 0 to 2 pi scale. So all these ones here was if we stretched out to 6 pi. But we're throwing them into the 0 to 2 pi because that's what we're staying in. And then we know it shrinks. So it's kind of like we looked at it as a terms if it was stretched all the way out like it's supposed to, but then took that and then put to 0 to 2 pi by dividing it by 3, which we thought we were going to do. Right? That 1/3. So look, this is the cool thing. Pi over 12, right? The biggest one is now 19 pi over 12. That's less than 2 pi. So we now have them within our restrictions. So dividing those all by 3 throws it all back into where we want it for the domain. So it's kind of like lining things out, what it would be if we didn't solve for x, and then solving for x real quick, and these are the actual values that happen. So these 1, 2, 3s actually go here.
And your graph change.
Like that. Those are the actual values. Okay? A lot of fraction stuff there. I know it's confusing, but any questions? So again, let me explain one more time. So what we did was, we looked at it as a term as if we know it's going to happen. Since the 3 is going to make this graph happen 3 times within 2 pi, we looked at that graph stretched out to normal 6 pi. And then we divided all those values by 3 to get it back into the 2 pi scale. Okay? That's what the bottom row is.
Will we always have to do that?
We always have to do all of that? No, not always, no. We'll do some where we're kind of looking at the understanding of why it's happening. Okay? But no, you don't have to find the originals and divide them all by 3. Algebraically, we'll do that a little bit. So you will do this divide by 3 here. Okay, so the general then is x is pi over 12 plus 2 pi over 3. And then it's pi over 4 plus 2 pi over 3. The 3 comes from, right, our period's 2 over 3, right? Because you take the 2 pi. We did this earlier. You take that, and you go 2 pi divided by that for your period, right? Or you times it by 1 over 3. So 2 pi over 3 is where that's coming from. So pi over 12 plus the period of 2 pi over 3, pi over 4 plus 2 pi over 3. There. So it's actually this one gets me to that one. This one gets me to that one. So this was 8. It was 8 pi over 4 plus 1. So 8 plus 1 is 9. 8 pi over 4 plus 3 is 11. Remember, they're happening in groups of 2. The 8 pi over 4 is 2 pi, right? 8 over 4 is 2. So we're adding 2 pi to this one, adding 2 pi to that one, adding 2 pi to this one, adding 2 pi to that one. And this, they're acting in pairs. Yep. Good. Anything else? And n. Oh, yeah. The n's are on here. Thank you. N and n. Thanks, Leah. Okay, and then NEI, of course. All right, so let's look at what we've covered here for this part. Good job. Verify the solutions using a graphical approach. The general solution consists of 2 sets of answers which differ by 2 pi over 3 because the graph is sine 3x, has a period 2 pi over 3. So that's why the general solution differs by 2 pi over 3 because of the period, which we kind of know. Okay, so solving multiple angles equations. Let's do some examples now. Okay, it's got 2 example sets and we're done. Okay, solving multiple angle equation using algebraic approach. Okay, so an algebraic approach, following steps we can go with. Find the domain of the multiple angle. So what's our domain that we're going with? Solve for multiple angles between 0 and 2 pi with the cast rule as your reference, so knowing we're positive or we're negative. Add the period of the trig graph of the multiple angle to each answer in step 2 until you cover the domain in step 1. That's what they're talking about. So let's look at this one. So sine of 2x equals negative 1/2. So let's go ahead and talk about that 2. This graph is going to act as it's going to what? So the last one was 3, it went to 6 pi. This 2 is going to go to 4 pi. Good. So 4 pi tells me, and what that tells me, guys, is that we have 2 groups of answers. That's how I think about this. Right, because we know that 2x is going to make the graph shrink down and happen twice more often than we've normally. If it's 4, then it would happen 4 times more, so that'd be it'd be 8 pi. Yeah. Okay. So then we're going to look at x from 0 to 4 pi. That's why I wrote this. So x from 0 to 4 pi, just like we did with the, whoops, not equal to 0, but. Okay. So, all right. So what's the reference angle now for when sine's 1/2? So y is 1/2. We've done this one quite a bit today. 30, which is what in radians? Pi over 6. So reference angle, pi over 6. Okay? And so now it's negative. So what quadrants are we in? Three. Bottom, right? Bottom. Sine being negative is bottom, because sine's y. Okay? So this is what we're going to do. So we are going to kind of do that process, Bob. We're not completely outdone, okay? But we are not going to say, we're going to say, so 2x, the values on a scale to 4 pi in which this happens, okay, is, so what's pi over 6 in the quadrant 3? That's 7 pi over 6. What's it in quadrant 4? That's 11 pi over 6. And then I'm going to add 2 pi to that to get to the 4 pi section. Okay, so in terms of 6, it's 12 pi over 6 I'm going to use, right? 12 over 6 is 2. 12 plus the 7, 19 pi over 6. 12 plus the 11, 23 pi over 6. I'll pause there. Two pi to each pair. Yeah, so these pairs are in our normal set. We add 12 to both of them to get to the next set of 2 pi, because we have a set in 2 pi and we have a set in 4 pi. So these answers, 1, 2, are right here. These answers are in this set. To get here, we add 2 pi to the previous. And 2 pi is over 6. Now the last thing, we're solving for what? What are we solving for? X. So I can divide by 2 now. And so then, where x equals 7 pi over 12, yep, 11 pi over 12, 19 pi over 12, and 23 pi over 12. And the cool thing again, 23 over 12 is slightly smaller than 2, so you're back in your normal spot you should be. Because we're solving for x. Dividing by 2, guys, are fractions. It simply means you multiply 2 to the bottom. So all I did is I took all those values I had, I multiplied 6 by 2 for 12. Yeah. But why divide by 2? Because we're solving for x. That's still the goal. We are solving for x. We're solving right now. I know that's kind of been an afterthought. We've been talking about a lot of stuff, but we are solving for x. So those are the 4 values between 0 and 2 pi for this graph. Okay. Now, graphically, guys, if you guys put this in graphically, these values would come up. This is how you can get it in exact form without your calculator with graph. But you can still find the intersection and do the stuff to find exact. That's still fine. This is how you do it without using your calculator. Okay? General solution. So the general solution would be, so it'd be 7 pi over 12 plus 12, so plus pi n. And it'd be 11 pi over 12 plus pi n. How am I getting pi n? From 7 to 19 is 1 pi. Sure. Okay. So the general solution consists of answers which differ by pi radians, because that's the period. The general solution consists of answers which differ by pi and radians, because the graph of y sine 2x has a period of pi. Why does it have a period of pi? Well, we go 2 pi divided by 2, right? That's how the period becomes pi. We know that. Or 2 pi times a half, whichever you want to do. All right. Last one. You guys are doing good. I know you wore out. It's been a solid week. Feels like it, but we still have like almost 30 minutes. Yeah. All right, here we go. Let's look at this one. We'll finish up so we can stop thinking this is taking a long time. Distance above the ground of a student on a circular Ferris wheel is given by this equation. So obviously we need the plus 5 so we don't hit the ground. Okay, don't hit the ground of Ferris wheel. That's not fun. Okay, so -4 cosine pi over 12t plus 5, where h is the distance above the ground in meters and t is the time in seconds when the student is at the lowest point of the ride. Okay, for the first time. So determine the time it takes for the Ferris wheel to make a complete rotation. So that's essentially, we're trying to figure out the what? The period, right? And so the period is pi over 12, okay, times 2 pi. Sorry, divided by. You write that. It's 2 pi divided by pi over 12, which we flip and multiply. That's what I was trying to do. Like that. So that's giving me the time for the Ferris wheel to go completely around, which is 24. So it takes 24 seconds for this Ferris wheel to make a complete turn. Yeah, it seems pretty fast. Okay, maybe it's smaller. Okay, so the pi's cancel. 2 times 12 if you're not seeing the 24. Remember, if you're given, we've talked about this and I'll say it again. If you're given a b with radians in it, your period is going to be numerical because the pi's will cancel. If you're given a b in numbers, your period's going to be in radians with the pi because the pi won't cancel. Okay, so that's what happened, right? It went away, 24 seconds. Algebraic determine the time during the first minute of the ride wherein the student is 7 meters above the ground. So that means we're solving for the height to be 7. So 7 is my y. All right, so we are going to go 7 equals -4 cos pi over 12t plus 5. That's the first 24 seconds. So it says in the first minute, but we know a ferrule rotation is 24 seconds, so what's going to happen is we're going to have 2 answers, right? Because it goes all the way around twice in a minute. Does that make sense? So there's going to be a couple times we're at 7. So actually it's going to be 4, right? Because it's Ferris wheel, it's going to be 7, 7, 24 seconds, 7, 7, 48 seconds. We might even hit another one. Okay? All right, so let's see what we get here. So we're just going to solve. So just solve this. What would you guys do? What's that? Subtract the 5. Okay, now what? Dividing by 4. I like what I'm seeing here because we are really happy with -1/2. We know what that means. Okay, so here we are. So now we ask ourselves, This is where we're at the point we just learned today. We are at cosine being negative. So what quadrants am I in? 2 and 3, correct. Quadrant 2, quadrant 3. I'm on the left side. What's my reference angle? So where is it? Negative 1/2. Negative 1/2 for cosine. Yep, it's going to be the 60 cut, which is what we are in radians. 2 pi over 3 here, and 4 pi over 3. Good job. Okay, 4 pi over 3, right? 2 pi over 3 and 4 pi over 3. Okay, so what we do is, this is what we do. This is all we have to do. This is the algebra part. It's actually not that bad. We're setting this equal to that. Setting this equal to that. So we're going to go pi over 12 t equals 2 pi over 3, solve for t. Pi over 12 t equals 4 pi over 3. The cool part is the pi's are going to cancel. You guys see that? Pi on both sides, right? These are the two time points for the first turn. These are the first time points for the first turn, which you're going to be at 7 meters. And it makes sense, right? Because you have a Ferris wheel. So as I start here, I'm at 7. I'm at 7, right? It's going to happen at 2 locations. So what you're going to do is, we'll times the 12, divide the pi. Hope you guys understand the pi's are going to cancel. So essentially, it's going to be 12 times 2, 24, divided by 3, 8. 8 is that time point. So 8 seconds, you're at 7 meters. No. It'd be 24, 1, because 24 is a period, not 30. And 2, there's 2 in the first 24 seconds. So yes, for your second one, we're going to add 24 to it. Correct, but not 30. Okay. So this one here, again, the pi's cancel. Times the 12, we get 48 over 3, which is 16. Yeah. Those are the locations where cosine's negative 1/2 on your unit circle. That's on your unit circle, Ty. We're in the, yeah. Yeah, we're there and there. Yeah, the pi over 12 was given to me, right? Pi over 12 comes from there. Okay? So what we figured out, guys, on your Ferris wheel's regular rotation, 24 seconds, at 8 and 16 is the time it's at 7 meters. Okay? But we know we want for a minute. So then what Bobber said to finish this, we're done. We add 24 to this. We get 32. We add 24 to this. We get 40. And then if I go 24 plus 32, am I under a minute still? What's 32 plus 24? 56. I'm just under a minute. So the last one is 56. That's why I told you that first one might happen again in a minute, and it did. So you have 5 times in 1 minute that the Ferris wheel is at 7 meters. Okay? I'll let you guys verify that graphically. I will stop the video, but you can ask questions.